Okay, so I1 is very quickly calculated by taking the difference of V and VTH and dividing that by the sum of the two resistances. So the current I1 flowing in this direction is given by V minus VTH divided by R1 plus RTH. And there I have it. Notice that by converting the arbitrary network N into the Thevenin equivalent, I turned this into a really trivial problem where I could write down I1 simply by inspection. Finally, before we move off the topic of the Thevenin network and the Thevenin method, it is worthwhile staring at this pattern here, comprising the voltage source in series with the resistance, and the equation V equals VTH plus RTHI that governs the VI relation of the Thevenin pattern. So it's worthwhile looking at this graphically as well. So I'm going to show you a little graph here with and plot the IV relation for this Thevenin pattern. And usually the way you draw these IV relations is you try to find out an open circuit voltage. In other words, try to find out the voltage when the current is zero. So open circuit voltage when I is zero. So in this case, when I is set to zero and there's no current, then the open circuit voltage here is simply VTH. So V equals VTH. So in other words, when the current is zero, my voltage is VTH. So I've found one point on the IV relation for the Thevenin equivalent pattern. Next, let me find out the short circuit current. And for the short circuit, V is set to zero. So in this case, I apply a short circuit here, and I'm going to measure the current. So the current in this case is given, I is given by minus VTH divided by RTH. Notice that because VTS is positive here, current flows down in this direction and is given by VTH divided by RTH, and that is in a direction opposite to I, and so therefore I get the minus sign. So my current is given by minus VTH divided by RTH, and so for 0 volts I get some current here, and that is given by VTH divided by RTH. And so this voltage here is my open circuit voltage, and this current here is my short circuit current. Okay, so this is my short circuit current, and that's my open circuit voltage, and my IV relation is drawn by simply connecting the 2 points. And the slope of this curve is given by 1 divided by RTH. So, so here again, to very quickly summarize, I've drawn the IV relation for this Thevenin pattern, which has a VTH in series with a RTH, and I found 2 points on the IV relation. One is on the voltage axis and one is on the current axis by measuring the open circuit voltage and the short circuit current and then drawing a line through them.